Thank you. Perfect. Thank you for that warm welcome. So my talk, unlike the other talks from that you heard yesterday, is going to be very technical, so buckle up. But before I start into the actual content, I just wanted to give you, for some of you who are, let's say, considering a career in data science and machine learning, just to show you what I've been doing over the past, let's say, 10 years. So I finished high school in Gymnasium van de Arbeid in Fatos, and then I went to United Kingdom to study computer science. So I graduated in 2012 from King's College London. And then I opened the initiative called Data Science Initiative, which is a meetup.com community. The reason why I opened was because I was really fearful of public speaking. So every time I went, let's say, to speak anywhere in any audience of any size, I would literally shake and just get nervous and sweat, and it was a very uncomfortable experience. So I thought, what is one way to overcome that fear? Open a community and just go in front of people, right? Face your fear, head on. And that's what I did. So over the past, let's say, 10 years, I think it's going to be in September, our Jubilee celebration, we have garnered over 4,000 members, and we organize events around data science, around machine learning, AI. So it's a really versatile community that we have there. In 2014, I graduated with a master's in data warehouses and business intelligence from the University of Greenwich. And then in the same year, around June, I joined the Oracle Corporation as a BI consultant and later got promoted to cloud architect. And in there, I was working primarily with big data and ML technologies that Oracle had, but also from the open source tech stack. 2008, I made the transition to Microsoft as a cloud solution architect, where I currently reside. And here I work with large organizations, helping them adopt AI, not just as a experimental kind of thing, but also how to put those AI models into production, how to solve real-world problems. Today I'm going to be talking to you about large language models and how you can actually put these models into production. How do you use them from a practical perspective? So my talk is going to be very, very technical. So before I talk about state of LLMs, I want to maybe level set a little bit and just give you a brief overview of natural language processing. So the way I'm going to approach this, I'm going to first talk about what these technologies are all about, what happens underneath the hood, so how do they work, and then where can you use them, where can you apply them from a practical perspective. So let's focus on the what for now. So NLP, or natural language processing, is not a new thing. It's been around for decades, since the 1945 with John McCarthy and Marvin Minsky, where they first developed the first n-gram models back in Stanford. And fast forward to, let's say, 2006, where we had the first neural language models. And then we had recursive neural networks, sequential models, which culminated around 2013 with the advent of GPU compute, which became prevalent around those years. And then, of course, in 2017, Google released this paper called Attention is All You Need, which kind of changed the game quite dramatically because we introduced this concept called attention mechanism, which allows you to train and understand have a contextual understanding from a piece of text much better than what you can do before. And of course, in ChatGPT got released around November 2022, and the whole field just exploded after that. So, as I mentioned, GPT-2, which is a precursor of ChatGPT, it's a model that was released in February 2019. And when this model obviously got released, as you can see here, I've kind of tried to capture as much as I can the various different types of models that have been, let's say, developed ever since. So obviously GPT-3, GPT-4, developed from Microsoft, Llama, which came recently, developed by Meta AI, or formerly known as Facebook. Google released their own BARD model, which is based on this Palm model. OpenAI Assistant was released recently by this famous YouTuber called Yannick Kilcher. Definitely check his videos. And of course, loads and loads of frameworks and tools to make your job easier to navigate these GPT, or let's say transformer-based models, put them into production. So tools like LangChain, very famous tool for managing your prompts. Tools like Guidance, which was released from Microsoft very recently, again, around grounding, how you develop and generate these prompts, and loads more. And of course, evaluation, which is a very important topic in terms of how we evaluate the accuracy and the output that you generate with these models. So there's this whole debate around, open source and closed source models. And I really like this illustration by Irene Soleiman, who kind of depicts this, let's say, from the far end, from the left end there, you have these fully closed models, which are, let's say, under the courtesy of these specific companies like Google, OpenAI, and so on and so forth. And then you have, of course, OpenAI and Microsoft, let's say, exposing these products as APIs, which is that hosted access and cloud-based APIs. So you can access them as an API, just call them, send a prompt with some text, and get some output, and integrate that within your applications. And of course, there are completely open source models out there, like Crayon, OPT, Bloom from Big Science, GPT-J from Eleuther AI. These are open source models that have been developed by a large consortium of researchers, NLP, and machine learning engineers. And today they're available for download as well. So let's see. So in terms of like the various type of models that we have within, I don't know if you know, but OpenAI was discussed yesterday by Mira Murati and Pamela Mishkin, and what they do as an OpenAI company, right? So OpenAI is a company on its own. However, we, as Microsoft, have a very, very close partnership with OpenAI. So all the models that OpenAI develops, they first land on the Azure cloud, which is Microsoft Cloud Service. And we, of course, enable OpenAI to train these models in large-scale compute environments. So for instance, the GPT-3 model, which was trained on a massive supercluster on Azure. If you were to train that model yourself on an NVIDIA T100 GPU compute, it would take you 355 years to train that model. So you can appreciate the scale required and the complexity involved to train these models, and of course the financial resources that are needed to be able to make that to be a reality. So of course, we at Microsoft offered a massive supercluster compute cluster for OpenAI to train these models, and we did a similar thing for GPT-4. GPT-4 is a bit of an interesting one, of course. You will see the differences between GPT-4 and GPT-3 soon, but obviously it's a much larger model, and it takes more time to train and to develop. So this is actually a good illustration of the differences between ChatGPT, and when I say ChatGPT, I mean GPT 3.5 Turbo. So GPT 3.5 Turbo is when we refer to ChatGPT, and then GPT-4 is a variant of that, or let's say a more powerful model of that, with more parameters and more data trained into it. But this is a great example of the differences between the two. So I definitely recommend you to read this paper called Sparks of Artificial General Intelligence, Early Experiments with GPT-4. It's a very lengthy paper, so definitely if you're not doing anything on a weekend, download it, read it. It's a very interesting one, some very bold statements there about AGI. Take them with a grain of salt, but nonetheless, very interesting. So what we have here is, we have a book, 9 eggs, a laptop, a bottle, and a nail, and we want to tell both of these algorithms to stack them on top of each other and see what the results we get. So rather than me having you read this responses of both of these models, I try to visualize this. So this is the difference. Right, so if you look at ChatGPT, it orders these in a very peculiar manner, like you would never, for example, balance the eggs on top of a nail. Whereas if you look at GPT-4, it has very strong common sense reasoning capabilities. So it does have, for example, some, let's say, I don't want to use the word understanding because that is a very interesting, it's not a good word to use for these models. But it does have some, let's say, some knowledge about the surface area of each of these objects. For example, the surface area of the laptop being balanced on top of the eggs instead of balancing the bottle on top of the eggs, which could, you would put all the pressure in 2 or 3 eggs, so you would break them. So it's really interesting how the model understands those intricacies and is able to stack them correctly. And as Pamela alluded to yesterday in her presentation, OpenAI released recently the Whisper model, which is a speech-to-text transcription model. So you can take an audio file and you can transcribe it into a piece of text. And this is a library that is today available in Python, so you can just pip install it and you will have it ready for you to try it and experiment with. And of course, we at Microsoft, we are working, as I mentioned, closely with OpenAI. And we're trying to integrate OpenAI capabilities, especially the GPT-4 model, for code generation and code, let's say, co-piloting. So we call it GitHub Copilot. So now, you probably have heard this term, it's almost the age of co-pilots. We have co-pilots nowadays for everything. There's co-pilots for Office 365 products, for Power BI, for PVA, for loads of Microsoft products. And one of them is the VS Code integration of GitHub Copilot. So you can use it to, let's say, as an assistant to help you with coding tasks. So what I've done is just to show you, just to illustrate an example, is this is going to generate an HTML code. So it's not a super advanced, but just to land the message home. What I've said is, this is what I've written myself. So I said, can you please generate an HTML page with a background light blue color? Add this text called Welcome to DOKU-TECH 2023. Center the text horizontally and vertically. Add a button with these 50 pixels and 100 pixels dimensions. Put the button underneath the text. When I click the button, the text should, the background color of the page should change, and the text should change to the most amazing event in the Balkans. So when I press enter, this is what GPT will do for you. It will generate the code automatically. As I press enter, it will just start understanding the question that I asked, and it will start generating the CSS styles. This is all HTML code. It will generate the body, the JavaScript, the button, and everything. And then once you launch the website in the browser, you'll be able to see that, click the button, and you get that, right? Super amazing. So you can do quite a lot of things with this. This is obviously the most simplistic example that I could show, but you could do so many things. I use this tool on a daily basis to help me with a lot of coding tasks that I have to deal with customers usually nowadays. And of course, as Pamela mentioned yesterday, you can use OpenAI models for image generation. So you give it a piece of a text, like an astronaut riding a horse in a photorealistic style, and it generates an image doing that. And you obviously saw Ralph's presentation yesterday. He had these amazing pictures that was entirely made up by these models. So quite a lot of things that you can do with these. Here's me saying to the model, to Dolly, it's a warm, sunny weather, a tech-savvy audience, yourself, listening to speakers in a tech conference called DOKU-TECH in Pristina, Kosovo, talking about artificial intelligence, and this is what it generated. Doesn't look like this ambience here, but it's more or less, let's say, more sunny, it's outside. Maybe what it would look like in Prizren, maybe. So yeah, so also you can use, let's say, Ralph's words from yesterday, stretching the creativity of human imagination. So here we have an example of Vincent van Gogh, which is the picture of Starry Night. So you can use image generation technologies like Dolly, Midjourney, Stable Diffusions to, let's say, extend the imagination of the original author. So what would it look like if Vincent van Gogh had a bigger canvas? What would that painting look like? So you can actually extend horizontally, vertically, how that would look like. Of course, if you're a film producer, what you can do as well is, let's say you want to generate an animation. What you can do, this is the Flintstones. I don't know if you know Flintstones. It's a famous cartoon animation. When I was young, I used to watch it, I think. I still remember some bits of it. But essentially what you can do is you can generate the script of an animation and give it those scripts parts like this. Then you say for each script, for each bit of the parts of the script, generate image frames, and it will start generating frames. And you say, okay, generate even more frames, so go even more granular in terms of image frame generation. So it goes even more granular. Then you say, okay, go even more further granularity. So then you can use all these frames to generate a complete animated movie. So quite powerful what you can do today to bring concepts into reality and show them to your audience. Now, you know what these technologies can do, and this is just kind of talking to you about the coding aspect, the text generation aspect, the image generation aspect. So you may be wondering, okay, how do these technologies work under the hood? So traditionally, when we talk about natural language processing, we would have, for each task, such as topic classification, image detection, sentiment analysis, entity extraction, and so forth, we would have separate models that we would train and maintain over time to do these particular individual tasks. This was cumbersome, fragmented, it took time, and it didn't have, for example, any contextual awareness across these tasks. You could never share the learnings across these tasks. So what we're doing with these transformer-based models, because these are transformer-based models, GPT and all these variants, we're, let's say, converging them into one model, which we call now foundation models. And within that foundation model, what we can do now is we can input text data, image data, speech data, and train that foundation model to understand and adapt to loads of different tasks. And the way we adapt that, I'll show that shortly, but you can adapt it to question answering, sentiment analysis, information extraction, image captioning, object recognition, and so on and so forth. Loads and loads of use cases and examples that you can adapt these models to. And as I mentioned, GPT-3 is one of those models that are used, that is, let's say, one of those foundation models that was released by OpenAI. It's available on Azure, Microsoft's cloud, as an API. We use that for, let's say, enterprise customers. So any customer that is concerned about data privacy, compliance, security, scalability, usually they come to us as Microsoft to allow them to use these technologies in a much more scalable and much more secure and compliant fashion. So that's why you see this, these two logos converging and, let's say, collaborating. Microsoft has invested over $10 billion in OpenAI, and we have a massive amount in terms of shares in the company itself. So we have a very, very close partnership with them. So the GPT-3 model training architecture looks pretty much like this. This is a 30,000 view of how that model looks like. So what we do is we take a lot of data, such as the Common Crawl dataset, Web Text 2, Text 1, Wikipedia, and these are billions and billions of tokens. Of course, we cannot just put these tokens into the model right away. We have to represent them into some numerical fashion. So we use a process called word embeddings, which I will talk about very shortly. We convert all these tokens that comes from these massive amounts of data sets, and we convert them into these numerical vectors. We feed them into this transformer model, which is a decoder-only architecture. And then because it's a decoder architecture and it leverages this concept of multi-attention mechanisms, we can parallelize the training on large compute clusters, which was not able to be done before. You probably have heard of BERT models released by Google. That's an encoder-decoder model, which is really difficult to scale. With the decoder one and the attention mechanism, we can scale this to large clusters of compute. And the tokenization and embeddings is a very important concept. That's why I want to drill down a little bit here. Because we're going to use this a lot in the industry today, and we're going to be seeing an example of this on Albanian text shortly, and towards the end of this presentation. But what happens is, we take a piece of text, such as this, the animal didn't cross the street because it was too tired. We represent that piece of string into a bytecode representation, which is this first line of numbers. And then for each bytecode representation, we take and generate an embedding vector. An embedding vector is this green array of numbers. Usually it's about 1,000. And when you hear the term n-dimensional, we just mean that it's 1,000 dimensions in that vector. Once we have that vector, we can do quite a lot of damage with it. We can use it for so many scenarios. And I'll show you an example of how we can use that. But once you have these models trained, how can you actually use them? As I mentioned, for traditionally, when we wanted to do sentiment analysis or entity recognition, we would have to call a specific API for each of those tasks. Nowadays, the programming language, if you will, for these models becomes the prompt itself. So here, what I'm saying is, decide whether a phrase sentiment is positive, neutral, or negative. And I'm passing in the phrase, how can I help you today? And it gives me a positive sentiment for that phrase. So just by giving that prompt, that command in the form of a natural language, I'm able to tell the model what to do. Similarly, for entity extraction, I'm saying extract the name of this person in this text, and I'll give it the text, my name is Simon, order status, and it gives me the name Simon. Same thing for summarizing text. So I'm saying summarize this conversation between agent and customer. I give it the conversation, and it's summarized, customer is calling about an order. So these are this is the programming language of these models. This is how you dictate what these models are supposed to do. You give them a prompt with your data, and you generate the outcome, which is what you see here. And then there's two things that I want to make you aware of. You're going to hear about these quite a lot, fine-tuning and embeddings. Embeddings is what I talked about, that tokenization and embedding process. Fine-tuning is a way of taking domain-specific data. So if you're working in biology, chemistry, financial services, telco, whatever, and you want to, let's say you're getting some results, but you're not happy with the results, you can fine-tune the model to be more accurate on your data. So you can upload paired examples of expected, so a prompt with a text and the expected outcome that you expect as a human. You let's say, input thousands of those examples, and the model is able to learn using a process called transfer learning. So it only learns the last few layers of the model and doesn't actually train the whole model again, because that will take ages and is very expensive. So once that model is fine-tuned, is hosted on a dedicated compute, is provided to you for use, you only have access to that, no one else has access to that. Embeddings is another approach where we take unstructured text data, we generate the numerical representation of each of those data sets, And then we're able to do quite a lot of stuff with it. So you can do semantic search using various metrics, such as Euclidean distance, cosine similarity, Manhattan distance, and so on and so forth. You can cluster the text into different, let's say, semantic clusters, and so on and so forth. So you can do quite a lot of interesting things with that. And you probably, obviously, we mentioned GPT-3, we mentioned all those various different open source models and other models as well. Really what made the difference in terms of user adoption and this whole proliferation of ChatGPT that you're so, let's say, used to nowadays, is this concept of reinforcement learning from human feedback. This is how OpenAI trained the ChatGPT. So we had GPT-3, and then we had ChatGPT, which was trained, as you can see, on an instruction-based data set. So this is a conversational AI data set. We fine-tune the model using that technique that I mentioned earlier, and then we provide loads of these examples to a large test set of users, and they rate the answers that the model gives. So they put a thumbs up, thumbs down, and the model is rewarded for positive or thumbs ups, and is punished for thumbs down. And over time, the model seems to learn quite dramatically how to improve itself over time, and that's why this ChatGPT looks so appealing to the audience today, right? It's so natural, it's so conversational, it's in the form of a dialogue, so people really resonate with it. So this is probably one of those methods that is really giving that edge to these models. Okay, now that we know what these technologies are, now we know how pretty much more or less how they work under the hood, where can you apply them? Now with Microsoft, obviously, we have Azure OpenAI Service, as I mentioned, and we use that for our enterprise scale customers. So I work with telcos, with financial services, with oil and gas companies, with public sector companies, National Health Service in UK, and so on and so forth, loads of them. And usually what we do is we have, let's say, some of these are some of the most common use cases that we're seeing out there in the industry. So usually we work mostly with language today, not so much with Codex and DALL-E. Of course, Codex is used within GitHub Copilot, so developers have access to that already. But for language, for summarization, for instance, we have call center transcript summarization, we have product and service feedback, social media trend analysis. You can use it for generating marketing content, writing paragraphs from bullets, long format text, and so on and so forth. The opportunities and the use cases are endless of where you can apply this technology, because we are essentially mimicking the cognitive capabilities of the human brain in terms of language. And with language, as we all know, we can do quite a lot of things. So here's an example of a media kind of space. So you have a news broadcast, and what you do is you take the transcript of that news broadcast in a text format. You pass that to Azure OpenAI, and then you can do it for both content analysis or content creation. So for content analysis, you may do stuff like topic classification, what this news broadcast is about, entity extraction, who was mentioned, which organizations, which people, keyword extraction, human activities, fossil fuels, and so on and so forth. Question answering, so you can actually ask a question to that news broadcast text and get a response back. You can use it to generate video summarizations of that original news broadcast. You can use it to generate scripts, and so on and so forth. Or if you want to, let's say, if you're a news broadcast like a telegraphy.com or some other portal, they can use this to generate a complete article in their platform. For sports and entertainment, here's an example. And this is just kind of illustrating how you can use, I think we've got some of these questions before, how you can use ChatGPT to query your structured data sets, so your databases. Because we get that a lot from our customers, right? So how can we actually do that? Today, ChatGPT or these GPT-based models, they work very well on unstructured data sets, not unstructured data sets. And we don't actually recommend you to use this for large structured data sets. For that, you use analytical engines and query-based engines like SQL and so on and so forth. But if you wanted to use this, you would pass, for example, a text like this, and you say, can you please convert this into a SQL statement? And then run that SQL statement against my database. And then you get all the outcome back as a result. So this is where you can use ChatGPT to generate the code that these engines use to interact with you. So that's one example where you can do that. Another one is this retail example, where you can use, as I mentioned, that concept of word embeddings. So you get the customer product database with loads of unstructured descriptions of products. You embed them into a vector representation. You store those embeddings into a vector database, and then you search for the word couch. you take the couch word, you generate an embedding for that, and you compare the embeddings to find the most relevant products as part of that process. And I'll show you a more concrete example of this. And a marketing example here is where you can generate, using DALL-E, you can generate images given different, let's say, constraints that you put as part of the query. And you can use that to generate marketing, brand campaigns, test that with your users, you leverage A/B testing techniques, and then regenerate them to fit your user audience much better. But also you can use it for code and web development, just like we saw in that previous example. Here's a very typical example. This is one use case where it's really one of the most famous use cases, really, around call center analytics. And as you know, every organization nowadays has a call center function. So how can you use these technologies like OpenAI to intelligently extract information from these call transcripts and do something about them? This is an architecture that we have in Microsoft Azure, and we're using speech-to-text to transcribe the call, get the call transcript, send it to OpenAI, visualize it, extract all those information that we could extract using prompts. So quite powerful example. This is an example, for instance, what you can do with that. So you have a call, which is the transcript here. You generate the conversation summary. You can look at the transcript between the agent and the customer in that call. You can extract the overall sentiment of the call. You can extract what this call was about. So in this case, category health. You can extract the entities recognized, the key topics discussed between the agent and the customer. And you're going to ask questions against the call without you having to read the whole thing. So you say, what was the issue of the customer faced? And it will give you a response that is only grounded on this conversation, nowhere else. And then you can list out conversations that happened before that are very similar to this call. So an agent looking to resolve a problem for a customer can look at what other agents did in the past with a similar problem. Here's another one, a very famous one that we're working with loads of customers, which is the semantic answering with Azure OpenAI Service. So you have a large repository of unstructured data sets, and you want to use OpenAI to search content on that data set. Again, this is using some Azure services. I listed the requirements there. This is available on GitHub today. You can actually deploy this with a single click of a button, assuming that you have these requirements listed there. But it will deploy this entire architecture for you, and then you can query the service. You can just upload your data and query the service as if you were using on your own data. So this is what I did actually for some Albanian documents. So I took some documents like kontrata e punës, kontrata për ndërmjetësim, and all these things, and I just fed that into the model to generate the embedding. So for each page of those documents, I generate an embedding, so this vector representation that you see here. And then I say, okay, giving a new query, si përcaktohet orari i punës, I generate an embedding for that query as well, and then I do a similarity matching between the vector of the query and each of the vectors of the text that I've embedded. And at the end, I get the similarity score for each document, given my query, and I use the similarity score, the highest one, retrieve the content of that document. So in this case, document A is the most similar one to my query, and then I say, give me the query of the user, si përcaktohet orari i punës, give me the content of that page, send it to OpenAI, and give me the actual answer so I can show that back to the user, which is super, super amazing, and customers love this. So pretty good. So this is, for example, a demo exactly of that. So I deployed this, by the way, in a couple of hours, this whole thing that you see here. So I ask the question, let's do that, si përcaktohet orari i punës, and now it's going to go and calculate all those metrics that you saw there. And it's going to generate the answer, and the answer is grounded on those documents only, so it's not actually hitting the OpenAI service, like the public one. And it's going to give you a precise answer to your question. And by the way, it's using terminologies that are not exact match in the text. It's not actually just retrieving what exists in the text. It's actually answering using its own, let's say, words, but keeping the semantic understanding or semantic context the same as the original document. Cool. So, and lastly, I'm going to end it here. I'm just going to leave this as a message from GPT-4. I'm not going to read this. It's quite a lengthy one. But it's amazing what he can do in terms of generation. I was going to put a voiceover on this and read it, but it's going to take quite a lot of time to read it. So maybe I can just leave it here while I accept questions from you guys. And thank you for listening.